to produce 20 tons of wheat per hectare in the next 20 years. So we're looking to modify photosynthesis, nitrogen uptake use efficiency, using genetic modification at the moment. And that target is to sort of, as I say, 20 tons of wheat. So we're looking into the future from that point of view, and we're testing these deeper rooting grasses on one of our grassland experiments down in the West Country. So yes, we're looking into the future, but I suppose I'm thinking about the now and what can be done in the next 5 to 10 years rather than in the 20 to 30 year.
But those 20 tons can come also from perennials?
Possibly. Jerry's smiling. We'll see.
Yeah, thank you. Thanks so much. That was a wonderful overview. I wonder if so. Your data is on a per hectare basis mostly,
yes,
without much mention of yields.
Yeah.
So have you considered on a per yield basis? And I ask that because I can imagine a situation where one system might result in a lot of greenhouse gas emissions, but also a tremendous amount of grain production, for example.
Yeah.
That would be preferable over a low greenhouse gas but
yes,
low yield system anyway.
Yeah. There's a very nice paper by Van Groningen, I think, and that group, where they've looked at nitrous oxide emissions, and there's essentially a minimum, or at least a degree that you should go if you calculate the emissions on the basis of productivity. And it's clear that if we want to produce more food and we want to mitigate climate change, we need to look at emissions per unit of product. And that gets you some very different answers, as you were saying. And there's clearly an optimum fertilizer application, an optimum system, which gives you the minimum in terms of global change. And we've also done it in the context of, well, we've called it overall sustainability, looking at biodiversity, looking at climate change, greenhouse